This video will give examples with statistical measures. Find the measures of center for the data. So remember that our measures of center are the mode, median, and the mean. The mode is the most common number. So if we look at our data set, we see that we have 1 3, we have 2 1s, 2 8s, and 2 4s. And there's no number that is here 3 times. So that means that we have actually 3 modes. And our modes are the ones that we've seen twice. So that would be 1, 4, and 8. The median is the middle number, and in order to find that, we have to arrange our data in ascending order. So I'm going to have 1, 1, 2, 3, 4, 4, 5, 8, 8, 9, and 128. So I'm going to cross off numbers at the ends and slowly work my way in towards the middle. And since we had an odd number of numbers, our median was just 4. Alright, the mean is the sum of all of our numbers divided by the total number of numbers. So that would be equal to 1 plus 3 divided by, we have a total of 11 numbers. And if you do the arithmetic, you find that our mean is equal to about 15.72. Okay, now let's analyze which of these was the best measure of center. Our mode gave us 3 answers, so that probably was not a very good summary of the data. The median gave a 4, and all of the numbers do seem to be somewhat around 4, except for the 128, which is an outlier. Our mean was 15.72, but that doesn't seem to be a very good summary of the data because none of our numbers were anywhere near 15.72. What happened was that the mean was strongly influenced by the presence of the outlier, 128, while the median was not. So in this case, the median was a more robust measure of center because it was not influenced by the outlier. And if we were to report the data, we would want to use the median to summarize it. Our class just took a test. The average was a 95, but Sam the slacker scored a 70. Sam tells his mom the standard deviation. Which of these would she be more upset about? If the standard deviation was 1, then that would mean that almost all of the class got scores very similar to 95. And that would mean that Sam getting a 70 is very bad. If, however, the standard deviation were 15, then that would mean that a lot of students got scores much lower than 95. So Sam is not the only one to get a score around 70. This means that his mom would be much more upset about a standard deviation of 1 as opposed to 15. Find the standard deviation of the data set. I'm going to begin by just writing down the formula for the standard deviation. It's the square root of 1 over n, sum from 1 to n of each of the numbers, subtracted the mean, squared. Okay, so our first step is to find x bar, the average. This is equal to the sum of all of the numbers, divided by the total number of numbers, which is 5. So we find that our mean is equal to 2. Now, we're going to sum up the distances of each of these numbers from the average. So this part is equal to 1 minus 2 squared, plus 3 minus 2 squared, 4 minus 2 squared, 2 minus 2 squared, plus 0 minus 2 squared. So if we add up all of those, what we end up with is 1 plus 1 plus, here we have 2 squared, so that's 4, 0, and another 4, or just 10. Okay, so now we've already found this portion of the formula for the standard deviation. We can keep on going and plug in what we found here. So standard deviation is the square root of 1 over n times this quantity here, which is 10. And we know that n is equal to 5, so the standard deviation is equal to the square root of 10 over 5, or the square root of 2. And that's our final answer.